New stuff today. We're looking at relations. How fun. Relations in math can be represented by a set of order pairs. Taking some notes, by the way. So if you have this this printed out, you can just fill in the blanks. Otherwise, you might have to write all this down. Unless, of course, you already know it from last year. So a relation is a set of ordered pairs. The domain is a set of all the, hopefully you remember this, domain are your x values, and your range is a set of all the y values. And then independent and dependent. So independent is just another name for x, so that's the domain. And the dependent variable is the y value or the range. Okay. So x, domain, independent, we're all talking about the same thing. Range, y, and dependent are all talking about the same thing. Okay. So next part, what is a function? So function says for each x value, there is exactly one unique, I think it's the one we want here, y value. Did I say that backwards? No, I did not say that. I hate this definition. If it was me, if I'm trying to remember to be a function, I always say function x does not repeat. 4 words, okay? If you want to be a function, x cannot repeat or does not repeat. Okay. And then we add a couple new words, specific types of functions. So once you get past this first word, it says, is it a function? If you say yes, then we can classify it further. So this first one is a one-to-one function. And this basically is like, it's like going the other way. So each y value, what does I want to say? Does I want to say range? Each domain, what? I don't know. I'll trust. I don't really like filling the blanks. So each domain compares to one, or each domain, yeah, compares to one unique range. So more simply, say one-to-one, say y does not repeat, okay? And we'll see some examples of what that looks like in different situations. But there's the idea. To be a function, x does not repeat. To be a one-to-one function, y cannot repeat. Okay, on to functions, a little bit more out there. Say each of the, I don't even remember how these blanks go. Good thing I have my answer key. That's why I copied it. Each range corresponds to the domain. Sure, why not? So to give you an idea of what that looks like, let's actually look at our examples here. And really this is only going to come up in mappings. Is what we want to say is every y value listed is actually used. Okay? So like in this case we have 1, 1, 0, 3, 6, -2, 3, and 5, -4. So everything listed in the range has an arrow pointing to it. So we can say this is an onto function. Okay? Now if you have either a set of points or a table, if it's a function, it will always be an onto function. Because every y value has to be matched up with some x value, because you can't have a table that's just only a y value, right? Every y will always have some x. Okay? So the only time it won't be, I'll give you a non-example here, and this is also number 2 later on to help you out. So if we look here, it's listed out, but we have this number that's listed in the range, but it's not actually pointed to. So it wouldn't actually be included in the range, and this would not be an onto function. Okay? So to be onto, if it's in a mapping, everything in the range needs to be pointed to. There's your short version of what to look for. Okay, and to be both one-to-one and onto, it just has to meet both of the requirements. So each x has to be paired with one y, and each range has to correspond to the domain. There you go, there's your bonus. So if you want to fill in the rest, here's the answers, you can pause it now. All right, let's finish the examples. So let's see, determine whether it's a function and then what kind of function. Then what is the domain and range? So we'll start off with domain and range. So we open with the little curly braces. Domain are all the x values. And ideally we want to put these in order from least to greatest. So we would say -5 and then 0. Since we have more than one 0, you don't list them both. Okay, you only put a number one time. So -5, 0, 3. Okay, we do the same thing for range. Let's pick a different color. Got a lot of red today. Range is all of our unique y values. Again, order from least to greatest. So we have -7, then 0, 1, and 4. Okay, so is this a function? So we said to be a function, x can't repeat. Does x repeat? Yes, it repeats at the number 0. So this is not a function. So as soon as you see it's not a function, if it says, okay, classify that function further, you say, no, I'm done. If it's not a function, it can't be any specific kind of function. Not any. Okay, all right, that's it. So our second one, domain and range. So same idea. So domain, we list all the unique x values. So we have -2, 1, 3, 5. Okay, what's the range? So same thing, we just list them out. Let's see, -4, 0, 3, 6. So is that a function? Does x repeat? So on a mapping, if x repeated, you would have more than one arrow coming from the same x value. That is not the case here. So this is definitely a function. And then we said, what type of function is it? We already said it was an onto function because all of everything in our range is used. And we said to be a one-to-one function that y should not repeat. So in this case, we see each of our y values is used just once. So this is also a 1-to-1. If this wasn't one-to-one, what it would look like is you would have two arrows pointing to the same point, right? So if this was the case, this would no longer be one-to-one. This actually wouldn't be a function at all anymore because then it would have 2 points coming from 5, okay? But even if this was a function, like if we got rid of this 5, -4 and replaced it with 5, 6, it would no longer be one-to-one because the 6 would be repeated. Okay, there you go. All right, let's see. Then we have a table, same idea. So we list out our x values. So we have 1, 2, 3, 4. That's nice. And then our range, we have 5. We have 8. 5 gets repeated, so we won't put it a second time. We're only going to put the unique values. Is this a function? Does x repeat? No, it does not. So it is a function. What type is it? Is it one-to-one? Does y repeat? We say yes. Since it repeats at 5, it can no longer be a one-to-one function. But is it an onto function? Does every x have y? Does every y have an x? Yes. This is an onto function. Like I said before, if it's a function and it's in a table or a set of points, it's always going to be at least onto. Okay. All right, that's the first part. That's the hard part. The rest is super easy. So discrete and continuous, the big difference here, discrete is just a set of individual points. And a continuous is a line or a curve. Okay. And then a vertical line test. I'm not sure why this is over here because that's Should have gone with the first part. As to check, is to test. I don't know, let's go test. Tell whether the relation is a function. So the vertical line test. Oh, that we do need to know if it's a function. That makes sense. Okay, now that I think about it. So we say vertical line test, which means I can draw a vertical line, and if I put it anywhere on my function, or anywhere on my relation rather, if it only hits at one point, then it's a function. Okay? It's like these first two, no matter where I put this red line, I will only hit at most 1 point. These are both functions. But when I get to this old boy here, we see that it crosses at multiple points. So if I could put this red line anywhere and it hits more than one time, it's no longer a function. So I can, I don't want to do domain range anymore. You know how to do domain range this one. Okay. So we say, yes, this is a function. Yes, this is a function. No, this is not a function. Okay. But we can still do discrete and continuous because notice it doesn't say discrete function. It's just discrete relation. So even if it's not a function, you can still answer the rest. So we just want to know, is it a set of points or a line or curve? So our first one, we just have these 5 points. So this is discrete. This is a line. So that is continuous. This is a curve. That is continuous. Okay? Not too bad. Let's try them out. Come back with questions if you got them. Okay. Bye.